Welcome back. So today we're doing a deep dive into the telescope. And the question we're asking is, how did a simple tube with a couple of lenses from, the 1600s, how did that become the backbone of the entire global internet? Our mission here is to trace that journey, the technical evolution, the problems it solved, and its huge societal impact. And it all starts with, well, a bit of an accident and a failed patent. 1608, and this Dutch spectacle maker, Hans Lippershey, he applies for a patent. He claims he can make things miles away look close. And the story goes it might have been a total fluke, just, two children playing with lenses in his shop.
Right.
But the Dutch parliament, they reject the patent. They basically say the secret's already out. You can't keep this under wraps. But it was too late. The revolution had started.
What's so fascinating there is that the very first problem it solved wasn't scientific at all. It was purely practical.
Military.
Yeah. Exactly. Military. The Dutch government saw its value immediately during their War of Independence. All of a sudden, you have a tool for long-distance reconnaissance. A commander can now see 3, maybe 4 miles away. That's a huge battlefield advantage.
So it begins as a spyglass, but then Galileo hears about this Danish perspective glass in 1609. But how does he take that simple trick and turn it into a 20x scientific instrument? What was the specific hardware challenge he had to solve?
Oh, that technical jump was monumental. He didn't just copy the idea. He fundamentally re-engineered it. He started grinding his own lenses with just incredible precision, way beyond what anyone else was doing.
Right, so the precision was the key.
That was everything. And that new level of technical mastery solved another huge problem beyond the battlefield: navigation. Once he discovered Jupiter's 4 satellites, sailors could use them as a kind of a cosmic clock to calculate longitude at sea.
And this is where that precision breakthrough just causes this massive cultural upheaval. Galileo uses that same tool not to spot enemy ships, but to disprove 1,500 years of established science.
His observations were just undeniable. Mountains on the moon, moons orbiting another planet, the phases of Venus.
All things that shouldn't exist in the old model.
Exactly. It was direct visual evidence for Copernicus's heliocentric model. This wasn't just new tech, it was intellectual warfare.
And that raises this bigger question, right? How do we even know what's true?
Absolutely. The telescope really ushers in modern empirical science. The way we validate truth shifts completely. It moves from, philosophical speculation or what ancient authorities said to direct, measurable observation.
And the demand for better telescopes then cascades into all these other industries.
It had to. To get higher magnification without massive distortion, that problem called chromatic aberration, you needed better materials.
So they had to invent new stuff.
Right. They had to invent and perfect things like crown and flint glass, specific types of optical glass, and just holding those lenses perfectly steady drove huge advances in high-precision mechanical manufacturing that we still rely on today.
That technical thread, that need for precision, it obviously didn't stop there. Today, it's evolved way beyond visible light.
Oh, completely. We're now in the world of radio telescopes, space telescopes like Hubble.
And it's solving our most modern communication needs.
We've gone from seeing a few miles to locking a laser beam onto a tiny satellite hundreds of miles away in space. I mean, in 2024, a small 80-kilogram satellite hit 200 gigabits per second laser communication speed.
200. What does that actually mean?
It means that little satellite can transmit the data equivalent of over 24K movies per second.
Wow. So the societal challenge now is just coordination. We've got satellite, internet, and astronomy trying to use the same sky.
And you see technology being used to manage technology. Things like SpaceX's telescope avoidance tech. The satellites can actually shift or aim their beams away for a moment when they pass through a critical line of sight for an observatory.
A balancing act, then. Communication and science.
A very delicate one. So, when you look at this whole journey, it shows that these profound innovations, they often start by meeting really urgent practical needs, military reconnaissance, trade, navigation. Only after that do they spark the massive scientific and societal revolution. But maybe the deepest impact is this. The telescope forced humanity to finally realize its own smallness in the vastness of the universe. And that realization is humbling, of course, but paradoxically, it also inspires the courage for more exploration, for these huge international collaborations like the James Webb Space Telescope. And that realization of scale, that's a powerful thought for you to explore further.